All right, we'll try this. I might be a little close. I'm using the tripod for your sake, not mine. Let's see if I can get a little more in there. Okay, well, let's see. There it is. There, that's it. That's as good as I'm going to get it with the angle. Oh, wait. Oh, look at that. I can move my screen. Much better. Okay. Now if I can just slide it down a little bit. Okay. There we are. You're in that corner. I have to remember that. Well, as you know, working on this fan assembly, we had a couple variations of it. And in this case, I can get a little closer, maybe not. I don't know. A little light, maybe not. I don't know. Yeah, this guy, there it is. This guy worked, but he didn't quite have what we call the poop. My dad used to say, I was too short in the poop. I better let him handle it. So, but I did get it. The smoke test verified that we could make it work, and so I went back to the basics. I had the fan and the motor information. I also had my model. This is from Lionel. The problem with the Lionel is, look at the fan they use and the fan I'm using. Okay, I used a smaller fan. I can't really explain what happened or why, but that's it. And so their fan would fill up this cavity and give it lots of airflow. So the best thing I could do is take the ratios of dimensions and just try to scale mine down. So I'm optimizing my blower fan with a cavity that would work with it. So I did print a test piece before I went on, and as you can see, there's a lot of extra room in here. I didn't put the opening in yet on this particular piece, but I was test fitting to see a lot of room. It wants airspace around it. It wants headroom as well, and I think I've achieved that. I got a little piece of brass I can use. The headroom it asked for was about 2 millimeters in the closed end, you might think of it. This is the mounting plate for the motor. The motor would mount on it from this point. This was the fan, and this was the 2 millimeters of headroom that it asked for. That's how I make sure I got all my fittings properly. So when this is slid in and bolted down, we've got room for this part and this part up to that point, and that's that point. It fits. Okay. Now, when it spins, you're going to find a pretty large opening in here. That's 4 millimeters opening, which I know we did not have 4 millimeters. We might have had 1.5. Okay. The input I have left the same, which is about 2 millimeters. That didn't seem to be the constraint because these guys, they used a small hole in their board too. So I don't think the inlet is the issue. It's the resistance in the output. It's sort of like headers on a car. You get big open headers, it runs better even though you have the same intake carburetor and stuff. So that's kind of what we've done. And I didn't mind that because it cleaned this whole area up here and allowed me to remove that wall. So now the inlet, I can pull air in from down below, up a side. I'll be able to get a lot more access to the air. I'll be able to pump a lot more out, which will go right out. And so if my motor's running 3-4 volts and it's not hitting anything, it's not getting any resistance, we should be able to get a very smooth, reliable spin, and then a very high flow. This is what I'm shooting for. So this is the beta 2, penultimate, nearly done thing. So you can see these guys would fit in here. This bolts on, and then the motor comes on. So you put all this assembly together, and I have only 2 bolts. They attach one here and one down here to hold the motor in place, and it's on a sealed, 2 sealed surfaces here. I'm not going to use any sealant unless I feel I need to, if it's going to warp or something like that. I will say during the testing I found this assembly got warm, the motor got really warm, and I think it had some resistance hitting the fan. Some piece was hanging out and causing the motor to work harder. The motor should just fly rotating air, not bumping into things. So we're going to try to make sure we have a nice, quiet, free motion. It shouldn't quite be so loud either, okay? And then the air, we're going to make sure the air comes out. I'm going to do the smoke test at different angles. I have the smoke coming in down here, up here, see, you know, how well the smoke can get pulled in, and then see how well it's flowing out. And we'll do that test before I put it back in. I may not have time to put it back in. I just started the reprint. All kinds of goofy things happening. Ran out of, oh, my filament broke. I'm low on filament, but I have a brand new roll, so if I run out, I can thread it in right away and just continue. The machine will tell me, I'm taking a pause here because you ran out of filament, you fool. So I'll be watching it, don't worry. Anyway, so this is the device and what it's going to look like, how it's going to work. And let me back that away so we can just see a little more insight here. Let's take a whole body. Let's not just take a piece of it. Okay, we'll take the whole body, back that. I'll back it all the way up to the motor there. You can see how that works together. Okay, and we'll okay that. Then I use my little spin tool here, and you can look inside there. So I want you to see how big that opening is now. Pretty big. I wanted to put a little radius in here, but the machine was fighting me for some reason. He just didn't want to do that. I'm not sure what's going on, but I'm going to try it as it is. And I know it's a little off center. That's exactly how the Lionel folks had it. The air is coming around here. It sees an opening and it starts hitting that edge up here, and then it goes out. And it's just going to, once it starts, it's like cattle. They follow everything. So I think once it starts, it's going to come in here, spin in the middle, get thrown out to the sides, and then finally get thrown out the hole. And it all happens real fast, right? So I think, and if you look at this, like, wow, is this thing, so you've got this housing where the inlet and outlet is nice and tight. You got the inlet where you're capturing it. You're going to pull air in from low and medium. That's about all you can do with the location of where it is. And the outlet is going straight down, and this box is going to cover the hole in the floor, and it's just going to go like right down through the register in the floor. So that's how that's going to work, and it should be fine. And then if we want, I think I can grab these guys and say, let's make a move. Oh, I only have to do one at a time. The motor is in a different format, so he's going to be contrary about it. But let's make sure I got that in the right spot. Oh yeah, it looks good. I'll show you. Well, I can't show you. Anyway, it looks good. It's in the right spot. The holes line up is the main thing, and then the openings all do as well. You can see the openings on both sides lining up. So now we can pull the motor, get the motor in. For some reason, it's a different kind of body. It just doesn't want to work with these buddies. I don't know what the deal is. Just the way it is. Okay, fine. Oh, pushed him in too far. All right, there it is right there, and that's probably about as aligned as it will get. Okay, so that's what it looks like assembled. You see all those parts fit inside. I'm going to rotate this around to the back. I'm going to go this way, then I'm going to go this way and this way, and now I'm going to put it in the center. I'm going to start a section analysis down here. I hadn't done this before. I'm a little, I should have done it. So if we see an error, you're going to see it with me. It's not too pleasant, is it? So let's get this in here where we can get a nice big image. Okay, here we go. We're cutting down now. We're just cutting in slices like a loaf of bread, and we're just cutting it, and we're walking in on a slight angle just so that it shows better for me. So there's the mounting screw. Now we're entering the cavity. And remember, the fan and everything is still in there, so they're going to show up. It looks like they're a little too high right now. I'll have to check that. Boy, if that doesn't fit, I'm going to be in deep trouble, huh? Whoa, I thought I measured that right. What is going on here? Whoa. Wow. That's interesting. Didn't expect to see that. Let's get out of this. Let's get this back. Well, I can do it. Okay, that's all right. I can do this. Let's get him out of there. Let's get him way out of there. Okay. Now, I was pretty sure I measured this multiple times. Oh boy, here we go. Oh, he's too high. I see that. I don't know what's going on with that, but in any case, what we want to know is that going to fit in the hall? All right, so let's go down here. Let's measure something, okay? We're going to measure this plane to this end, and we've got 9.4. You can see it over here, 9.4 millimeters, okay? 9.4. Now, we're going to measure from this surface, so erase that setup, to the back plane. I think that's the back plane. And we got 8.7. That can't be right. Huh? Can that be right? 8.7. 8.7? What? 9.4 to 8.7? Well, I'm wasting my time making this part then. That's 0.7 long. 0.7. Now, it could be okay. I may not stop this because, remember, we have a 2 millimeter air gap. Oh, so if I add the 2 millimeter air gap, I've got 10.7. So I have a 0.7 space, instead of the 2 millimeters. I got a 0.7 millimeter. So let's look at that. Calipers, excuse me. That's 0.7. That's 2. Okay, 0.7 is a lot smaller, but it's not 0, and it's possible you can clean that up, but it's still. I've been doing this, so I'm going to go ahead and let it go. I think it's going to be okay. The other challenge I have to determine is how much room do I have on this back wall to push things back. I'm not quite sure where I am. Well, let's take a look and see. Let's go to my section analysis. Let's go start it here and let's go. Oh no, that's overlap there. I see that. Okay, so it gets thin on the left side. As you can see, right here is where it's the thinnest. So I can't just push it back anything I want. Okay. Let's pull it back out. The other thing I could do, I think, is bring this face out. Bring this face, unclick this. Let's say okay. I could bring this face out this way, 0.7. If that's what I need. Yeah, 0.7. 0.7 pushes this out. But I don't think, let's see how thick, let's see. This is 1 millimeter, okay, clear that. This is 15.5, so 16.5 millimeters. Okay, let's look at this again from the top. Clear that, come here, and come here, and we have 19. We got plenty, but let's come down here and look at this edge here, because this may have, that's 17.2. 17.2. I didn't write this down, did you? Sixteen, 17.4. 17.4 to 16.2, so it's going to hang over 2/10. You know what? I think we'll make 2/10. I'll make it work. Okay, well, what I'm going to do, I mean, I don't want to close that in anymore. I don't want to make that wall any thinner. So I'm going to pull it out 0.7. I'm going to do what's called a push-pull or face offset. I just pulled it out 0.7. You might have seen it move a little bit. So now it's 0.7, and that should give us the dimension we're looking for from the back wall to the front wall. 9.4. Yep. So we now have 9.4, which is what this said wasn't it? No, I got it wrong. Yeah, 9.4. And then I have my 2 millimeters, so 0.7, I got the 9.4. Okay, so the next time I print this, I'm going to use this. I'm going to save this right now. Boom. Okay, well, that was exciting. I wasn't expecting you to watch me see something I missed, but there it is. We seem to have a little extra room back there, so maybe this thing will fit in this test part. I just don't have time to stop and start again. It's already 5. I want to get this built and at least assembled, even if I can't run it. If I can get it assembled, I can do the smoke test in about 5 minutes. So we'll get that in, I'm hoping, before the day's over. Okay, well, I'll leave it at that. You saw what it looks like. It looks goofy. It is what it is. I think it's going to be okay. I think it's going to be fine. This is how it fits. You're inside the tender looking at the part. That's how it's going to look. It slides down, as you know, the 2 little slots. It just slides down into position and is held in place by those slots, and there's a slot here, so it's airtight on all 3 sides. The top lid comes down with a magnet. This opening is for the wiring to pop out, and I may or may not use that. I may close that off before the day's over. I just want to make sure that this goes in tight. I might even put a little grease on this just to make sure it's tight. I don't really want to glue it in because you may need to get it apart. And you want to make sure it's sealed at the bottom as well, so that is nice to do. And okay, I think that's it. I think it's going to be awesome. We'll find out. You'll find out with me. All right. I'll get back when I'm doing the smoke test. Later.